Hello again, grade 10s. This is video 3 of the examiner feedback and memo session. And in this video, we are going to cover question 5, the stoichiometry segment, and question 6, the vector segment. So for question 5, it was out of 28 marks. Therefore, you should have spent 30 minutes on this question. If we look at our little blurb, now you all should be getting used to the fact that I give you a little blurb, I give you a little backstory, which is actually meant to help you answer the questions that follow. Einstein is the unsung hero of the Back to the Future story. Without Einstein, Doc would not have made the breakthrough of time travel a reality. One of the essential components of energy is carbohydrates. Glucose is the building block of this macronutrient. Einstein requires a careful balance of carbohydrates to fuel his mascot role. So following this little blurb, you already know that we are going to probably work with carbohydrates or glucose. That should give you a clue. And from that, I've given you the actual synthesis equation for glucose. Okay, there is our glucose right over there. Okay, and I've even told you that thermal heat energy is absorbed during this reaction. So this particular little blurb gives you a lot of information to build upon with the questions that follow. We typically always start with a definition. So I wanted you to define the mole here, and remember it's the amount of substance that contains the same number of particles as 12 grams of the carbon-12 atom. 2 marks, all or nothing, said this before. The thing that changed here was for 5.2. If you guys remember, when I went through my videos on chemical reactions, when I gave you a backstory before we started stoichiometry, I explained to you the different reactions, the combustion, the synthesis, and the decomposition reactions. And I showed you that you can use a different reaction to predict the type of product, the phases of your products that you are going, the phases your products will be in. So when I say balance the above chemical reaction, all right, I want the phase. I want the phase. We changed this later during marking because it was thought that it was a little bit unfair to not have said include phases. I'm telling you now, include your phases. To me, that's a balanced chemical reaction. So I want phases. But for this particular assessment, we marked you with for 4 marks if all your coefficients were correct. So let's go look at question 5 over here. Question 5 is you needed to give me a mole ratio of 6,616. That is what I wanted. And I would have given you full marks here, 4 out of 4. 5.3. If you had read the above, you would have gotten 5.3. Some people didn't even answer this question. I think that's throwing marks away. What type of reaction is this? Exothermic or endothermic? Guys, energy is absorbed, it's endothermic. So for 2 marks, I wanted you to say endothermic, and I wanted you to say that energy is absorbed in this reaction. For question 5.4, here you needed to work out the mole. So can you see how we're slowly going through each section of your stoichiometry using glucose as an example, glucose as a means. If Einstein requires 15 grams of pure glucose a day, how many moles would that equate to? So you needed to work out your molecular mass, which is 180 grams per mole, and then you need to say 15 divided by 180, and you should get 0.08 mole. For 3 marks. Then for 5.5, okay, so 5.5, there was a slight, when we reviewed the papers, I realized that perhaps the phasing here, the phrasing of the question could have been misleading. And what I wanted was how many atoms there would be in 0.08 moles of glucose, and I didn't write that in. I said 24 atoms. I just said in 1 molecule of glucose. So if you wrote 24 in 1 molecule, you got marks here, you got moderated up. But if you had gone the whole way round and worked out how much in 0.08 moles of glucose, well done, thank you, that's what I was looking for. I wanted you to take moles times Avogadro's number times the number of atoms in the molecule. That's why it was for 3 marks and not just 1 mark for 24 atoms. So this was a little bit misleading in the exam, and it should have been rephrased to make it very clear as to what the examiner wants in hindsight. 5.8. 5.8. Find the percentage composition. Simple, guys. Simple, simple, simple. We look at the number of atoms divided by the molecular mass times by 100. I gave you a mark for each percentile, and that was out of 3, and everyone got that question. I did not provide carryover error here because I really believe that the molecular mass should have been worked out correctly in the previous question of 5.4, because molecular mass is pretty simple compared to other stoichiometry calculations. Now, once you had to do percentage composition, you had to, 5.7, here comes the stoichiometry. You guys had to figure out the mass of oxygen is released when 2,200 centimeter cubed of carbon dioxide reacts with water to produce glucose and oxygen. So I've given you the word equation in this question. And if we go back to my exam memo, you will see exactly how I've outlined how I want this. And this is how we mark it in many, many situations. Maybe in the future you might not get marked for the equation. You might not get a mark for the equation, but the rest you'll definitely get a mark for. So again, you got a mark for equation, for converting to decimeter cubed, for mole, okay, all right. So depending on your rounding, if you got 0.098 or 0.10 mole, you got the mark. Then your ratio, 6616. And last but not least, the mass. We were very lenient here, and I marked you correctly based on your rounding to get to the answer. All right, so that's nice. That's a pretty clear and concise marking. There's no way that you can really go wrong here, because it's very clear as to where we are marking you for each point. That ends the whole glucose story. The remainder of question 5 had to do with naming. So I had to bring in the naming. I had to bring in a bit of theory now. Now that you've done calculations and stoichiometry, let's look at a bit of theory. So I wanted to know, why do we use stock notation in chemistry? Just for 1 marks, and it just had to do, you just had to tell me that certain elements and transition metals shift and change, oxidization, and therefore that is why we use it, because it denotes the charge of the elements with varying valency. But the real answer here is, and I've given other options here, the one I was really looking for was the whole shift and change, and that's why we use the Roman numerals, because these elements don't have a fixed oxidization. 5.9.1, you had to name a compound, and it had to be beryllium hydrogen carbonate. If you didn't write the full thing correctly, I did not give you the answer because it was pretty obvious. Then 5.9.2, it had to be titanium bromide, and it had to be TiBr4. The name gives you the answer. And then 5.9.3 is a decomposition reaction. Okay, and here I wanted you to actually balance it out, but then afterwards, when we were marking the papers, we decided to not give you a mark for balancing, but just for the equation. If you just wrote out the equation. So if we look at the memo over here, you will see that the equation is going to be your manganese sulfide, and then you're going to have your manganese and your sulfide over here, right? So let's look at that. There we go. Done. So it only had to be a simple equation. You did not get a mark for the balancing. All right. That is that concludes stoichiometry. So what was in my mind when I said this? I really wanted to apply something different. I wanted to apply a little bit of bio in the question, and I wanted you guys to work it out from that and then give you some easier, straightforward questions to help you out if the other part of the section was a bit tricky. That was my plan. The last component of the exam has got to do with vectors. Now guys, it was only for 15 marks, so you should have spent only 15 minutes on this, okay? And we made it as simple as possible. However, the feedback I'm getting is that people really struggled with this section. I think the reason they struggled, it was the last section, people were tired, and maybe they did not pay full attention to everything that needed to be done. Here, let's look at the first one. It's saying, during a skateboard chase, Marty tries to evade Biff after defending his dad in the ice cream parlor. He borrows a 1955 version of the skateboard and maneuvers on the roads of Hill Valley Town Center. 6.1 and 6.2 are straight theoretical questions. So that's 4 marks. So even if you didn't know how to do any calculations, you didn't know how to apply any formula, if you had studied your theory, you would have gotten 4 marks here, because 6.1 is a definition, 6.2 is the difference between distance and displacement. Well, one is a scalar, one is a vector, one has got to do with a total path, and the other one has got to do with a straight path, which only considers a change in position from starting point to end point. 6.3, and it's only for 2 marks, guys. Only for 2 marks for 6.3.1. You had to read this little blurb quite well here, because he's traveling down the road for 55 meters at 15 kilometers an hour for 30 seconds. Then, before he turns, he grabs the back of an old truck, which is heading west. So you already know that he's going to be heading west. He was heading east, now he's heading west. He accelerates, so this is east, this is west. He accelerates while moving west with a truck. He accelerates while moving with the truck at 40 kilometers an hour for 200 meters for 40 seconds. So now you've got 2 different speeds and 2 different displacements, okay? 6.3.1 is asking you to draw a linear vector diagram, linear. So I didn't even ask you to draw a bearing or a compass, just linear, and it's only for 2 marks. And you've got to do it after 70 seconds. So after 70 seconds, so here is 30 seconds and here is 40 seconds. Okay, right, 5, 6, 7, so the entire distance then. What did he do? Guys, he turned 180 degrees. So therefore, if he was turning 180 degrees, you would show the vector his displacement. What did he have left after that? Okay, what did he have left? Because he has 55, he has 200 and 200, so that's everything. But what was his displacement? So what I wanted you to do, I'm sorry if you can't see it nicely on the memo, but what I wanted was 145 meters in the negative direction or in the west direction. So what I wanted was a north arrow, and then going towards the west, I wanted 14.5 centimeters based on a scale. So I wanted a scale and I wanted a resultant vector. More specifically, I wanted this here. This was what I wanted. I don't know if this is no, it's not going to work. Let's try the pencil. This is what I wanted here, this. And then your scale. Remember how important I told the scale was? Because if you read the question carefully, it's asking you to draw a linear vector, okay, after his resultant displacement, okay? So you have to minus 55 from 200, all right, because he is going in the opposite direction. All right, so this might have seemed a bit tricky, but guys, it was pretty, if you read carefully, you would have been able to work this out. If you had studied, you would be able to work it out. So if anything, this is a little bit of application of what you've learned of theory. The previous questions with pure theory. 6.3.2, I wanted you to calculate the average speed. Here, I wanted you to take the whole distance, remember speed takes distance into account, the whole distance, which is 255, divided by 70, which is the full time. So I wanted 3.64 meters per second. Another way of doing this is got to do with your conversions of kilometers to meters, and it also takes into account the time. So with physics, there are many ways to get to the same answer. So with physics, I don't mind as long as it makes sense. All right, as long as it makes sense. 1 or 2 people did the or. Majority of people did the straightforward. Okay. Then 6.3. 6.3. This was the one that was omitted from the final count of the exam. Why was it omitted? Because apparently some classes received information about acceleration that others didn't. Okay, in the last few lessons. So this was in your book. It definitely was in your book. Okay, but VF minus VI was not. So because of slight discrepancy, this was taken out. So the majority of you got extra 3 marks. That said, I'd like you to please look at this question. Calculate the acceleration of Marty after he grabs the back of the truck and travels for 6 seconds. So you already know what your time is. You already know what your time is. You already know what your velocity is. The velocity is 11.11 meters per second from the conversion from 40 kilometers an hour, because that's what the truck is doing. Okay, and you've got to think about your initial velocity. There was no initial velocity, so you just divided 11.11 meters per second divided by 6, and you should have gotten 1.86 meters per second. Alright, some people even use the V equals U plus AT formula, which we haven't even taught you yet. Alright, so I don't think this was completely unfair. I think this was definitely possible for you guys to answer, but it was omitted in the final count. So you all got an extra 3 marks. The last part is going to be you've got to figure out Marty's velocity before the 180 degree turn. So what was his displacement there? It was 55 meters. And if we look back up, guys, he was traveling 55 meters for 30 seconds. All right. So there, it's definitely going to be 1.83 meters per second east, and he's going east. Remember, with a vector, you always have to put the direction. If you don't put the direction, I'm going to minus a mark. You could have also just converted the 15 kilometers an hour to meters per second east, and you would have gotten the answer. Guys, that's also a short way of doing it. Okay? Because I've given you quite a bit of information, and it's telling you already what the meters per second is. So there's 2 ways of doing this here, depending on which variables you use. Now, I understand that this was a tricky part of the exam. I don't want you to worry, because we're going to be spending more time on this, and when it comes to the final exam at the end of the year, you will be more prepared for vectors and kinematics as well as equations of motion. Please contact myself or Mr. Ginsberg if you need any further help. This concludes video 3 of the examiner feedback. Have a great day further.